Hey guys, Mrs. Sands here. Sorry I can't be here, but we're still practicing reflections, which is what we did yesterday, so today shouldn't be too tough. In Google Classroom, you have your answers to last night's homework. If you could check that over, that would be fantastic. And you should write down the objective on the lines provided. Today, we're going to continue to practice reflections on the coordinate plane. And there is a do now for you to do on page 10. So if you could do that. So triangle ABC is shown on the coordinate grid, and its vertices are at 5, 8, which is here, 7, 3 is B, and 2, 4 is C. For number 1, they ask us to reflect triangle ABC across the y-axis. And then we have to label it A prime, B prime, C prime, and write down its coordinates. So remember, when we reflect, a point goes the same distance, just on the other side of the line of reflection. So I do like to highlight my line of reflection. So first they told me to use the y-axis. So there's my line of reflection. And I'll reflect point A. Point A is 1, 2, 3, 4, 5 units away. Go 1, 2, 3, 4, 5 units away. Call it A prime. B is 1, 2, 3, 4, 5, 6, 7. Go 1, 2, 3, 4, 5, 6, 7. And call it B prime. C is only 2 away. So C prime. Remember, you should always step back and look. Do the triangles look congruent? Congruent means same shape, same size. Now, when I'm graphing with this special pad that I use, it's hard for me to draw straight lines, so I apologize about that. A prime turned out to be at negative 5, 8. B prime is at negative 7, 3, and C prime is at negative 2, 4. Next, they ask us to reflect triangle ABC, so back to this original triangle, but now over the x-axis. So I'm going to highlight my x-axis. And I'm going to remember to reflect over that line. So I'm going to count how far away point A is from the x-axis. It's 1, 2, 3, 4, 5, 6, 7, 8. Go 1, 2, 3, 4, 5, 6, 7, 8. Here's my A prime. B is 1, 2, 3. Go 1, 2, 3. And C is 1, 2, 3, 4. So I go 1, 2, 3, 4. Again, these two triangles should look congruent. They should be the same shape, same size. Of course, when we do reflections, it is a reverse image. Remember, the orientation has changed, but they're still congruent figures. If I use tracing paper and traced triangle ABC, it would land perfectly on top of A prime, B prime, C prime, and perfectly on top of A double prime. I forgot these are double primes, and they are congruent. So A double prime, B double prime, C double prime. A double prime, when we go over the x-axis, is at 5, negative 8. B double prime over the x-axis is at 7, negative 3. And then finally, C double prime is at 2, negative 4. So then number 3 is an interesting question. What happens when the points are reflected over the x and y axis? Describe what happens to the coordinate points in both cases. So they're actually asking you about the numbers that I wrote down. Did you notice up here in number 1 when I reflected over the y-axis that the sign of the x changed, but the y stayed the same in all of these, right? It went from 7 to -7, but the y stayed a 3. The x went from 2 to -2, but the y stayed a 4. And something interesting happens when you go over the x-axis. So the x-coordinate stayed the same, but now the y-coordinate changed signs. So when you go over the y-axis, the y-coordinate stays the same, but the x-coordinate changes. And when you go over the x-axis, the x-coordinate stays the same, but the y-coordinate changes sign. We're going to write that down. So it's actually pretty easy to tell if you're doing a reflection over the x-axis or a reflection over the y-axis correctly, since it seems like the numbers stay the same, it's just one of them changes signs. So just remember, when you go over the x-axis, it stays the same. The y is the thing that changes signs. And when you go over the y-axis, the y stays the same. It's the x-coordinate that changes signs. To be honest with you, I usually don't remember that. It's so easy just to count boxes on the graph paper that I always just do a reflection correctly. So exercise 1. Now we're going to deal with the trapezoid called MNPQ. It's already graphed for us. An interesting fact about trapezoids is that there is at least one pair of parallel sides. Take a look right here. QM is parallel to PN, right? Those two sides are parallel. So a trapezoid has one pair of parallel sides. So let's name them. Remember, I can call it QM or MQ. It doesn't matter. QM. It's a line segment, so put that symbol above it. Is parallel to line segment PN. Now it's asking us to draw the image of MNPQ after reflection in the y-axis. So again, I want to go highlight my y-axis. And I'm going to count how far to the y-axis and go the same distance on the other side. So I'm going to do M first. M is 2 away, so I go 2 away on the other side. We'll call it M prime. Then Q is 2 away, so I go 2 away on the other side and call it Q prime. And then some people get confused now when they have to reflect N and P. It's the rule that we talked about yesterday. You count how many boxes to the line of reflection and go the same amount on the other side. So N is on the right side, so it has to end up on the left side to be called N prime. It's 1, 2, 3, 4, 5, 6 away. 1, 2, 3, 4, 5, 6 away. So it doesn't matter that part of this figure starts on the right and the other part starts on the left. Sometimes when we do reflections, they kind of like flip on top of themselves. There'll be like an overlap. And then I'll do my best in drawing straight lines. So again, if I had tracing paper, I'd be able to trace over the original figure and the new figure, and they would match up perfectly. They're just reverse images of each other. It asks us to state the coordinates. So M prime is at 2, 5. N prime is at -6, 9. P prime is at -6, -2. And Q prime. Q prime is at 2, 2. Exercise 2. So right triangle EFG. So as soon as they're calling it a right triangle, the only angle that could be right would be this one. So I'm going to put a box in there. Is going to be reflected in the line y equals 3. So I already graphed it for you. I made it dotted. I'm actually going to label this y equals 3. So now we really do have to count the points. It's not just like something's going to change sign. The numbers are even going to be different because it's not the x-axis and it's not the y-axis. So we really will count the distance that it is from the line of reflection and go the same distance on the other side. Is this line that I graphed, though, horizontal or vertical? Hopefully you said horizontal. We need to reflect it over that line. So I'll start with E. E is only one space away, so I go one space on the other side and call it E prime. I'm going to go to F now. It's 1, 2, 3, 4, 5, 6 to that dotted line. So I go 1, 2, 3, 4, 5, 6 on the other side and call it F prime. And then G is 2 away from the dotted line. So I go 2 on the other side and call it G prime. Let's very carefully write down these coordinates now. First, let me connect them. I'm really, really bad at drawing straight lines with this marker. Sorry about that. All right, so E prime. Now be careful. Right here is the origin, right? So when we name points, we start from the origin. E prime is at -3, because I went 3 to the left, and positive 1, 2, 3, 4, because I went 4 up. Remember, when we're naming points, it's always x comma y. Always start from the origin. Okay, always start from the origin. I don't care about that dotted line. That was just a line of reflection. F prime, start from your origin, is at 1, 2, 3, 4, 5, 6, 7 to the right. So it's a positive 7. And 1, 2, 3, 4, 5, 6, 7, 8, 9 up. 7, 9. And then G prime. G prime. Well, this was 7, 8, 9. So do you agree with me? It's 9 on the x-axis and 1, 2, 3, 4, 5 on the y-axis. So Sometimes people name points incorrectly when they're reflecting over like this dotted line. Please don't let the dotted line mess up you naming your points. You always go to the origin, always use the x and the y axis when stating coordinates. Exercise 3. So in the image shown, kite ABCD has been reflected across a line to produce kite A prime, B prime, C prime, D prime. And they want us to draw the line of reflection. So something important to know is that the line of reflection is like right in the middle between the pre-image and the image. Remember, each point went the same distance away from the line. So something we can do is maybe pick 2 points. I'm going to pick D and D prime and count how many boxes there are in between them. I'm just going to make this a little bit bigger so I can see better. There's 1, 2, 3, 4, 5, 6 boxes between them. I'm just going to erase that line that I drew. 6 boxes between them. So halfway, that would be 3, wouldn't it? So 1, 2, 3. Right here is the middle. And it should be a vertical line so that all points are the same distance, not just D, right? Take a look at A and A prime. A is 1, 2, 3, 4, 5, and A prime is 1, 2, 3, 4, 5, right? It's the same distance. That line of reflection is always the same distance from the pre-image to the image. So we drew the line. Part B asks us, is it horizontal or vertical? That's definitely a vertical line. What do you think the equation of that line is? I'm going to go up to here for a second and remind you that this dashed line in number 2 was the equation y equals 3. And notice it crossed the y-axis at the number 3. So what do you think this one would be called? Well, it's vertical. It's not horizontal like number 2. It's crossing the x-axis. So we start with x equals, and then we just look at what number it crossed at. It crossed at -2. So this is just our beginning introduction to horizontal and vertical lines. We're going to have a whole lesson on it in the future. But horizontal lines always cross the y-axis and vertical lines always cross the x-axis. So that's how come this equation had a y in it and this equation had an x in it. But that's it for today. So all you have to do is work on your homework. If you don't finish in class, you can finish at home. And I'll see you soon. See ya. Bye.